Hello student, welcome to the one more video session. This is Vasanth.nayak from Canara Engineering College. In this video, you will be learning today register model of ARM. Register model of ARM, or it's also called as programmer model or software model, or sometimes in exam they will just ask to explain registers of ARM. So the diagram shows the register model of ARM. So we know from my previous video I have explained there are 7 different modes in which ARM operates. ARM 7 operates. So before moving to the actual what is register mode, what are those 7 different modes? The 7 different modes are: one is system. Okay, let me write here. One is supervisor mode. One is supervisor mode. Supervisor mode. One is supervisor mode. Second one is user mode. User mode. Third one is system mode. System mode. Third one is system mode, and fourth one is interrupt request mode. Fifth one is fast interrupt request mode. Fast interrupt request mode. Sixth one, undefined mode. And seventh one is abort mode. So undefined and abort modes are error modes, error reporting mode. So these are the 7 different modes. But when you switch on your mobile, first while during the booting time it will go to supervisor mode. While booting, your mobile will be in supervisor mode. Once the mobile boots, it will be in 90% of the time it will be in the user mode. User mode is just like home mode of the mobile. It will remain in 90% of the time it will remain in the user mode. Suppose if it wants to execute some system related calls or system related function, it will move to system mode. So both user mode and system mode doesn't need any interrupter. So there are 7 interrupter. This 7 interrupter takes you to 5 different modes. There are 7 interrupts. Please remember, there are 7 interrupts, 7 modes. But to move to system mode and user mode, you don't require any interrupt. So 7 interrupt will take you to the rest of the 5 modes like supervisor mode, IRQ mode, FIQ mode, undefined mode, and abort mode. So then what are those 7 interrupts? What are those 7 interrupts? We'll see that one also first. So the 7 interrupts are: first one is RST. Second one is undefined. These are interrupt. I am talking about interrupt. Third one is prefetch abort. Fourth one is data abort. Fifth one is system abort. Sixth one is IRQ, seventh one is FIQ. So these are the 7 interrupts. Now system interrupt and reset interrupt and system abort interrupt. So reset interrupt and system abort interrupt, this one take the ARM processor into supervisor mode. It will take the ARM processor into supervisor mode. So it will take the ARM processor into supervisor mode. Please remember. Okay. Now pre-patch and data abort mode. Pre-patch abort and data abort interrupt take the ARM into abort mode. Abort mode. IRQ interrupt takes the ARM into IRQ mode. FIQ takes the ARM into FIQ mode. FIQ mode. So undefined takes the ARM processor into undefined mode. So students, as I said here, once again, there are 7 interrupts in ARM and 7 modes in ARM. 7 modes are supervisor mode, user mode. 7 modes are supervisor mode, user mode, system mode, IRQ mode, FIQ mode, undefined mode, abort mode. These are the 7 modes. But we have 7 interrupts. 7 interrupts are reset interrupts, undefined interrupt, pre-patch abort, data abort, system abort, IRQ and FIQ. Reset and system abort takes you to supervisor mode. Then undefined takes you to undefined mode. Pre-patch abort and data abort takes you to abort mode. Then IRQ takes you to IRQ mode and FIQ takes you to FIQ mode. Please remember, we have 7 interrupts. 7 interrupt will take you to 5 modes because user mode and system mode doesn't need any interrupt. So when you boot your mobile phone, it will be in 90% of the time, initially it will be in supervisor mode. From supervisor mode, it will move to the user mode. That is 90% of the time it will remain in user mode unless and until interrupt occurs. When interrupt occurs, it will move into various different modes depending on the interrupt. Now, students, you can see here, like let me zoom it. You can see here user and system mode has got 17 register, that is register R0 to R15, R0 to R15, register R0 to R15, 16 registers plus CPSR, current program status register. Totally 17 registers are there. So most of the registers in this 17 registers are called general purpose registers, except a few like LR, link register. You can see here LR, link register, SP, stack pointer, then PC, program counter. PC, program counter. So we know what is LR. LR is nothing but which provides a return address. You will come to know later. Then stack pointer, which points to the top of the stack. Normally stack is we know a set of memory location used by the programmer to store data, and which is accessed by using normally in Intel processor, which is accessed by using push and pop operation. But in ARM it is accessed by using store and load operation. So stack is accessed by using in ARM store and load operation. That is the one thing you have to remember. Other than that, program counter also we know. What is a program counter? Program counter indicates the address of the next instruction has to be executed, and in 17 register, R15 is termed as a program counter, R14 is called as a LR, R13 is called as a stack pointer register. Rest of the registers are known as a general purpose registers. Now we have one more register here, students. You can see we have one more register here, that is CPSR. CPSR is nothing but the current program status register, which is a flag register which indicates the various information about the various flags. Now, other than this, we have 20 more registers. Totally in ARM, we have 37 registers. I already told you about 17 registers. So 37 minus 17 is equal to, we have 20 more registers. As the mode changes, most of the register remains same, but few registers change its physical name. So there are, depending on the different mode, like here you can see fast interrupt request, supervisor mode, undefined mode, and abort mode. We have 5 link registers. You can see here 5 link registers. We have 5 stack pointer registers, and we have 5 SPSR registers. So like 5 link register, we have 5 link register plus 5 SPSR, 5 stack pointer register, 15 plus we have 5 more registers in fast interrupt request mode. You can see here 5 more registers in fast interrupt request mode, this. So totally we have 20 registers here. So 20 plus 17 is 37 registers are there in ARM. We have 37 registers are there in ARM. Now student, user and system mode is not different. Both are same. Most of the time your mobile or ARM processor remains in user mode only. Why I am using the term mobile? Because most of the modern generation mobile makes use of ARM processor or ARM microcontroller. So 90% of the time, 90% of the lifetime, ARM 7 processor remains in user mode. When there is any system call, it will move from user mode to system mode. To move from user mode to system mode, it doesn't require any interrupt. That means out of 7 modes, user and system mode doesn't require any interrupt. Like I can say system mode is somewhat it is a privilege mode, privilege mode of the user mode. It's a privilege mode of the user mode, where because in the user mode you have confined set of actions, but to do certain higher end actions you need to move into system mode. So now there are other modes like fast interrupt request mode, supervisor mode, undefined mode, and abort mode. To move this to this mode, ARM requires 7 interrupts. So whenever fast interrupt comes, it will move into fast interrupt request mode. Whenever whenever IRQ interrupt comes, it will move into this one, interrupt request mode. Whenever as I said earlier, based on the particular interrupt, it will move into supervisor mode or undefined mode or abort mode. Students, we know in any processor, let me draw here, in any processor, when it, if the interrupt comes, suppose this is the stage when the interrupt comes. Whenever interrupt comes, it will go to the interrupt service routine. It will execute the interrupt service routine. Then it will come to the the next instruction has to be executed position. So you think the processor is executing suppose the processor is executing this instruction, and this is the next instruction it has to execute. And when the interrupt comes, it goes to ISR, interrupt service routine. It will complete, it will execute ISR, and it will return to the next instruction has to be executed. That is the job of whenever interrupt comes, the processor will do this one. But in ARM, so when any processor move to the ISR, it will store the address of the next instruction to be executed. That will be there in PC, and it will store that, it will dump that address into stack, and after executing ISR, it will dump the content of stack where it is stored the program counter address to program counter, and it will execute the next instruction. But ARM will offers the access of stack, because stack is a memory, and memory access are slower than register. So, and ARM always supports register operations. So what ARM will do is it will store the address of the next instruction in link register of the particular interrupt. For example, just think ARM is in user mode, which received a fast interrupt request. It will move from this mode to fast interrupt request mode. That time it will store the program counter value. It will store the program counter value in LR of FIQ, and program counter is loaded with the ISR of FIQ, and it will jump to the FIQ's ISR, and it will execute that ISR. While returning, it will reload the link register value to the program counter, and it will start executing the next instruction. Similarly, whenever different interrupt comes, same procedure will be followed. So students, please remember, when it jumps to particular interrupt mode, depending on the particular interrupt request, particular mode, then program counter will be stored in the link register of that interrupt. For example, if it receives the interrupt request and it jumps, suppose if it receives IRQ interrupt and it jumps to the interrupt request mode, then program counter value will be stored in LR of IRQ. Similarly, program counter value will be sometimes stored in LR of supervisor if it jumps to supervisor mode. So now the question comes, what is the use of this LR? So this LR cannot be used as a general purpose register. It is a waste, because from user mode you cannot go back to any other mode. So from user mode you cannot go back to any other mode. So this LR will not be used most of the time, and it cannot be used as a general purpose register, because normally it is a link register. It cannot be used as a general purpose register. Now student, we will move to the other information. Now student, next we will move to the one more register, that is CPSR. What is CPSR? CPSR. Let me write here. CPSR means current program status register. Current program status register. What is the use of CPSR? CPSR will store flag information. CPSR will store flag information. Now think you are in your ARM processor in user mode, and it has executed some arithmetic and logic operation like AL operations, and some of the flags have changed. And those informations are there in CPSR. But in between, processor has got interrupt, and it will jump to the particular interrupt, and it will execute ISR related to that interrupt. In that also, it has it has modified some of the flags. In ISR also it has modified some of the flag. After executing ISR, it has to return to the original program. Now you tell me whether you want change flag information or original flag information. Of course, we want original flag information when we return to the user mode. So for that purpose, while jumping from user mode to the particular interrupt service mode, CPSR will be saved in SPSR, one more register, that is saved program status register. Saved program status register. It will be saved in one more register, SPSR. And while returning SPSR will be copied to the CPSR. So let me take you to the screen. So suppose you are in user mode. If you receive ARM processor will receive interrupt. Based on the interrupt, it will jump to the fast interrupt request mode. That time CPSR will be stored in SPSR. And if it does some changes to the flag based on the ISR routine, that will not affect the original information. Original flag informations are there in SPSR. After completing the ISR, SPSR will be copied to the CPSR. But you students, like this, we have 5 CSPSR based on the different modes. We have 5 SPSR. But we don't have SPSR in user mode. Why? Because from user mode you don't go back anywhere. All these SPSR will help you to move back to this user mode, but from user mode you don't go back anywhere. That's why we don't have SPSR in user mode. SPSR in user mode. So that is the use of SPSR. So students, we have discussed here now. We have total 20 registers, 5 LR register, link register, which will return the return address, which will hold the return address. Then we have 5 stack pointer address. Then we have 5 SPSR SPSR register, 5, total 15, and we have 5 registers in fast interrupt request mode. You will come to know later what is the requirement of these 5 extra registers in fast interrupt request mode. Totally we have 20 registers, 20 plus 17 registers in user mode. So totally we have 37 registers. So students, now the left out is stack pointer register and the register related to FIQ, fast interrupt request or fast interrupt request mode. That we will discuss now. So here you can see in the diagram you have stack pointer registers, 5 stack pointer registers in different modes. Each mode we have separate stack pointer registers. Totally we have 5 stack pointer registers. Now what is the use of the stack pointer register? What is the use of the stack pointer register? Why we need 5 stack pointer register? Let me explain you with this example. So student, you think like you are in user mode. And this is the stack. Think like this is the stack. This is the stack. Now you are in user mode, and in the user mode you have done some stack operation. I refer you means ARM processor by using push operation. So that time it will store the information in the top of the stack here. Somewhere, suppose this is a stack pointer, the information is stored. This is related to user mode. Meanwhile, you got ISR interrupt. And that interrupt will make you take you to the ISR. In ISR also you have done some push operation. Think like you have done some push operation. That time the information is stored in the top of the stack. So now the information here, it is related to ISR. Because of some problem, pop operation is not been done here. And you return from ISR to your original program. That time you need your original stack, right? So you will get information from the top of the stack here. That is, you will get information from the top of the stack here, like this one, and this is related to ISR. ISR what you have executed, not related to your user mode operation. That means your user program here behaves improperly. So in order to avoid that one, each mode here you can see has got sorry, each mode here has got its own stack pointer, so that each stack pointer point to the separate memory location in the memory, so that when it jumps to the any interrupt mode or any operating mode, like the information is stored in the particular stack pointer of that mode. Information is stored in the particular stack pointer register of that mode. So we have totally 5 stack pointer register. So now the last one is fast interrupt request mode. So what do you mean by fast interrupt request mode, or what is that fast interrupt request? So here fast interrupt request, we have an additional set of a new set of 5 registers, R8, R9, R10, R11, R12. This is a complete new set of registers. Why we are using this one? Let me explain this one once again. Let me explain this one. So you are in user mode. Once again, you are in user mode, and you are executing some operations, and registers contain some informations. Register contain some informations here. You got interrupt request. Now it will take you to ISR. In ISR also, ISR also make use of register. Make use of register. That means your original register value will got changed. So in order to avoid that one, what you will do, when you jump from jump to ISR of IRQ, you will save this register. You will save this register in memory. You will save this register in memory or stack. While returning back, you will copy this one from memory or stack. Copy of register. That means when you execute IRQ, you need to save the content of register into stack and copy the same to the register once you return from IRQ. Sorry, ISR. But when you use FIQ, now when you use FIQ will take you ISR of FIQ. I will write here FIQ. Then FIQ has got new set of register R8 to R8, R9, R10, R11, R12. 5 registers are there. So it is a new set of registers. FIQ will use this new set of register. That means you no need to store and retrieve the original register into stack. This will save you the time. So that's why FIQ is faster than IRQ. And in normal case, normal IRQ interrupt request is used. In critical case, FIQ used. When you use FIQ, registers are stored in new set of registers. Registers are copied to the new set of registers. Registers will not be copied to the new set of registers. FIQ will make use of new set of registers for operation in ISR. So original register will be maintained as it is. So that's why FIQ will be faster than IRQ. So students, so I have explained you all the registers of programmer model. We have total 37 registers. It is 17 general purpose register including LR, SR, LR, SP, PC. Other than that, we have 20 registers. So all these registers we have revised. So thank you for your cooperation. So we will meet in the next video with one more new concept. Thank you.